This is the comparison of the C# programming language with the Java programming language. While this focus of this session is mainly the programming language and their features, such a comparison will necessarily also consider some platform features and some library features. C#. By construct, C# is a relatively new language. Microsoft has studied existing languages such as Java and Object Pascal, and has changed some aspects of the language and runtime environment in response to perceived failure and difficulties with its predecessors. C# accommodates constructs more commonly found in languages such as C++, Delphi, and in recent C# versions, borrows from dynamic scripting languages such as Ruby and Python. C#3 adds SQL-like language integrated queries suit for querying data from collections, database or XML documents, building upon general-purpose language features, including lambda expression and extension methods to allow queries to be expressed and optimized for user types. Java. Java is older than C#. Compiled Java does not run on any operating system, but it does run on many of them. Windows, Unix, Linux, whatever. There are some issues with Java running on memory-constrained devices as the set of supported libraries must be reduced. Runtime environments. Java, the programming language, is designed to execute on the Java platform via the Java runtime environment. The Java platform includes the Java virtual machine as well as common set of libraries. C# is designed to execute on the common language runtime. Language. Object handling. Both C# and Java are designed from the group up as object-oriented languages using dynamic dispatch, which syntax similar to C++. Neither language is superset of C or C++. However, both mainly use garbage collection as a means of reclaiming memory resources rather than explicit declaration of memory. Both include thread synchronization mechanism as part of their language syntax. References. In both language, references are central concept. All instances of classes are by references. Both languages support the concept of weak references. An instance which is only referenced by weak references is liable for garbage collection just as if there were no references at all. In both languages, this feature is exposed through the associate libraries, even though it is really a core runtime feature. Pointers. C# allows use of pointers and corresponding pointer arithmetic. Pointers and pointer arithmetic are potentially unsafe in managed environment as they can be used to bypass the strict rule of object access. C# addresses that concern by requiring the code blocks or methods that use the feature be marked with the unsafe keyword, so that all clients of such code can be aware that the code may be less secure than otherwise. The compiler requires the unsafe switch to allow complication of a programs that use such code. Generally, unsafe code is either used to allow better interoperability with unmanaged APIs or system calls, or for performance reasons. For safety reasons, Java does not allow pointers or pointer arithmetic to be used at all. Data types. Both languages support the idea of primitive types, which are all value types in C# or .NET, except of string, which is reference type. C# has more primitive types than Java, with unsigned as well as signed integer type being supported, and a dynamical type for decimal floating point calculation. Java lacks unsigned type. In particular, Java lacks a primitive type of an unsigned byte, while C# bytes are unsigned by default. Strings are treated as object in both languages, but support for string literals provides specialized means of constructing them. Arrays. Arrays and collection type are also given significance in the syntax of both languages, thanks to an iterator base for each statement loop. In C#, an array corresponds to an object of array class, while in Java each array is a direct subclass of object class and does not implement an of the collection interface. C# has two multidimensional arrays, as well as the arrays of array that are available in Java. Multidimensional arrays can in some cases increase performance because of increased locality. Generics. Both languages now support generics programming, but they have taken different paths to its implementation. Generics in Java are language-only construction. They are implemented only in the compiler. The generated classified include generics signatures only in the form of metadata. The runtime has no knowledge of the generic type system, which means that JVM implementation only needed minimal updates to handle the new classes format. Callbacks and event handling. C# implements object-oriented method pointers in the form of delegates. A delegate is a special type which can capture a reference to an instance or static method if its signature is compatible. Multicast delegates are called events. Delegates provide support of event-driven programming. They are type safe reference to methods and can be combined to allow multicasting. To support them, there is special syntax to define events in classes and operations to register, unregister or combine event handlers. Delegate supports convariants and contravariants and can be created as anonymous method with full-featured closure semantics. In .NET, closures and anonymous delegates are syntactic sugar. Java does not have a language-level construct like the C# delegates, but use plain object-oriented design. The observer anonymous inner classes are commonly used to implement the listener, allowing you to define the body of the classes and create an instance of it in single point in the code.